Okay, so on question 9, it's another question involving E, and we're explaining why is it not equal to this little fraction. So you might be tempted to just put that into the calculator, of course. Put that in the calculator, divide it, see what we get. So 271,801 divided by 99990. And if I just type in E, alpha, no, not alpha, second E, hit enter, wait a minute, it is exactly the same. But really it's not, and it's not because we know that the decimal numbers are supposed to go on past what we have here on the screen. If I go back here to 8, remember that you have 45, 90, 45, dot, 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 even more digits past that. And even more so, this is a fraction, which implies that that part is rational. However, E is totally irrational. And the definition of irrational number says, in part, that you cannot write an irrational number as the ratio of two integers. You can't make it into a fraction like this. So that's why it's not equal to that, even though it looks like it on the calculator screen. Okay, so number 10, we've got ourselves a fractal. So a fractal is created by this process called iteration. You do something to your shape, and then you do it again and again and again. So the process of this one is you take yourself a square, you break it up into like a grid of 9 pieces, like so, and you're going to remove this one, this one, this one, this one, as you can see in the next picture. And at the next stage, you break each one of these little pieces up into 9, and then you want to remove this one, this one, this one, and this one, as you can see in the next picture. You do that to all of your little blocks. You just keep going to infinity. So I want to write myself a function that gives the area of this cross-stitch fractal at stage n, assuming that at stage 0 it has an area of 1. So if I look at the pattern here, if I just look at the numbers, I can get what the function is going to be without even worrying about the fractal. So I can see that from the first one to the second one, or from 0 to 1, it just looks like I multiplied times 5/9. Okay, big deal. I move on from the next one, and the 5 changes 25/9 to an 81. Well, that just looks like this is 5 squared, and this is 9 squared. I move on to the next one, 125 over 729. This just looks like it is 5 cubed over 9 cubed. So as you can see, I'm just taking powers of 5 to the 9ths. And this is the same thing as 5/9 raised to the 0 power. So my function should be the area is equal to 5/9 raised to the n power. And we could put a little 1 here, or if it had a different area to start out, we could put that little number right out in front, but this is adequate. Now if I just looked at the pictures and was trying to get this function, I can see that I'm starting with a full area of 1, and every single time I'm just preserving 5 pieces of it. 1, 2, 3, 4, 5. Now each one of these, I'm going to preserve 5 pieces of it. So 5 in this one, this one, this one, this one, and this one. 5 times 5 gives you 25 of them. Moving on to the next one, each one of these pieces you'll preserve 5. So 5 or 25 times 5 gives you 125. Also, you might agree that since I broke this up into 9 pieces, each one of these is 1/9. 1, 2, 3, 4, 5. That's 5/9. And so that's where all the rest of the numbers come from. Okay, number 11. According to this function here, what's going to happen to the area of this as n approaches infinity? Well, this is going to get closer and closer and closer to 0. If you were to graph this, this would be an exponential decay function where 0 was your asymptote, your horizontal asymptote. So your actual area is going to approach 0.